Hello, this video is going to show how we can achieve functional safety with Rowley CrossWorks for ARM. Connected to my laptop at the moment, I have this evaluation board. It's an nRF52 from Nordic Semiconductor. Now, this is the Rowley IDE. It's called CrossStudio for ARM, and inside here I've created a simple project for that evaluation board. And what I'd like to be able to do is, first of all, let's check this actually executes. So let's go and do a build. All right, so that's now successfully built. We have this ELF file. So let's debug on the target. So that's downloaded, that's executing, and we should be able to step into this code, step over it, and we can see that's now executing. So as the code executes, I'd like to be able to find out, well, how much of this code have we actually exercised? Which statements have we exercised and which ones have we not exercised? I'd also like to be able to look at this code and see, well, is it compliant to a standard such as MISRA? And also maybe measure a number of metrics on the code, getting an idea of, well, how complex is this code? So let's close that down and let's go to TBvision. Inside TBvision, I've already done the analysis, so we can simply right click and we can do a code review. In this particular case, we can see the code is not compliant. We have a number of different violations, and I'm able to simply double click on a violation. It opens up my editor, which is Notepad++ in this particular case, and we can see I should have put a U here to indicate that's an unsigned value. All right, let's close that down and let's look at maybe the some of the metrics. Let's take a look at a system call graph. The system call graph is going to show us all the functions. We can see how they're interconnected, and I can put this into various different modes, such as this one gives us an idea of maintainability. We've measured a metric such as the cyclomatic complexity, and I can sort and I can find the most complex function. It's this integer to ASCII. Well, let's view that as a flow graph. And so this is going to give us a graphical representation of the code. If I was to click on this block of code, we can see it corresponds to this block over here. What about this one? Well, that corresponds to the block inside there. Now, what I want to be able to do is to execute this code, and I want to measure the coverage. So we're going to instrument it and put probes at the start and at the end of each block. So let's close that down and let's go into here and let's go and perform the dynamic analysis. So I want to generate the instrument program, I want to build it, execute it, and then measure the coverage. So let's start that. Now, this is starting to execute. We can see it's generating the instrument program. It built it. It downloaded it to the target. We've got the results from the target. And now we're going to be able to see, well, what coverage did we obtain? So to do that, we go back to our system call graph. And on the system call graph, we're going to be able to put this now into a mode that shows us the coverage. So here we can see very clearly where we have coverage, and for the integer to ASCII, we don't have 100% coverage. Well, let's see which parts of the code we've not executed. So again, we can go to the flow graph, and we can see very clearly we have some branches here that have not been executed, but also more importantly, we have blocks of statements that have not been executed. So if I want to get coverage for these parts of the code, then we can use the unit testing tool TBrun. So let's go and invoke TBrun. Now, this is TBrun, and what I'm going to do is I'm going to open a sequence of test cases that I've previously created for the integer to ASCII function. And there I've got 7 test cases, and for each one of these we can see that I've specified inputs and expected outputs. So let's go and execute this on the target and check with those inputs we get the outputs. And there, those have executed, and we can see the tests have passed, which means with these inputs we got the outputs that we're expecting over here. At the same time, we can now take a look at the coverage, and if we find our integer to ASCII function, we can now see we have a 100% statement, 100% branch decision, and 100% MCDC. Okay, so hopefully that's given you an idea of how we can achieve functional safety with the Rowley CrossWorks for ARM. If you'd like more information, then please don't hesitate to contact us at LDRA. Thank you.